Hello, everyone. Hopefully everybody has joined, and if you're still joining, we're just getting warm here. So hello and welcome to the first webinar in this series of PerfectScale webinars, where we're going to be talking all things Kubernetes, cloud native, DevOps platform, anything that can be of interest for the engineers who are doing the actual work. And of course, for the managers who want to know how to make the best out of these technologies. And today I'm very happy to have Birger, the CTO of PerfectScale, with me. Eli, how are you?
Hello, Anton. Thank you very much. Doing well. Thanks for having me here.
And thanks for having me. So let's start with a small introduction. Eli, a few words about yourself, your journey in the industry, and how you arrived at this point.
Yeah, so so currently I'm a CTO, co-founder and CTO of PerfectScale. Prior to that, I've spent many years managing DevOps, platform, and engineering, infrastructure engineering teams. I've built large-scale SaaS systems, mainly based on the Kubernetes in the recent years of my career.
Okay, so a lot of Kubernetes, and that's why we want to talk to you today, because we're talking about optimizing Kubernetes. And I'm Anton Weiss. I only joined PerfectScale recently, but before that, I was an implementation partner for a long time, helping our customers to optimize their Kubernetes clusters with the help of PerfectScale, fell in love with the product, fell in love with the team, and here I am today. And today, basically the subject of our webinar is something that you, Eli, have discovered about 2 years ago when you started PerfectScale, because you realized that you encountered a problem that didn't have a good enough solution at that time, right?
Yeah, that's correct. So I actually discovered the problem way, I mean, a few years beforehand, and eventually, when I haven't found a good solution, I decided that that's a good challenge to start with. And here is a little bit of how the challenge looked like. So I have built multiple large-scale Kubernetes systems, and now what I'm showing is a real picture from real clusters that I have built. So we did we started like everyone with some planning, then implementation. We learned, and eventually we launched the product, and everything was fine. But and we implemented all the needed stuff, like the horizontal pod autoscaler, the cluster autoscaler. We incorporated the spot instances, and we expected that our uptime will be something like this, very satisfying, 4 nines, 5 nines, and the cost will fluctuate according to the load. When we have more customers on the environment, we're scaling up automatically and having enough infrastructure and enough resources to serve them. And during the weekends, we scale down, so everything is super efficient. But the reality was a little bit different. The uptime wasn't so satisfying, and the cost constantly grew.
Yeah, so basically the main promise of cloud computing, of cloud native technology, the elasticity, the just-in-time resources, all of that wasn't getting fulfilled.
Yeah. Eventually, it seems like autoscaling works, but only if everything configured properly. So let's talk a little bit about those configurations. I had to dive.
Why is that happening?
Yeah. So to understand it, I dived all the layers down to understand where everything starts. And eventually, it's pretty simple. Kubernetes provides us with 4 knobs: the requests and the limits for CPU and the memory. For each and every container that we are running, for each and every pod that we are running, we must define those resources, or must tune those 4 knobs. The requests which are defining how much resources we would like to allocate, and the limits basically representing where we would like to stop resource consumption by particular container in order to protect the entire node or other neighbor, not becoming a busy neighbor on the same machine.
Yeah, okay. So we need to set this thing. What happens if we don't? Because in many clusters, I suppose worldwide, folks don't even bother to set this initially.
Oh yeah, we will dive this into a second, but as you mentioned, we're currently monitoring hundreds of clusters of different organizations, and we definitely see across the board. So, let's say around 40 to 70% of resources are wasted. They are over-provisioned. And in the same exact clusters, 20, 30% of workloads constantly struggling with underdefined resources. So let's dive into details and see for a second what happens when we are not defining resources as Kubernetes expect us to define them. So the first thing is requests. If we over provision the requests, okay, and I am a developer and I need to define how much CPU or how much memory I would like to assign to the container, in most of the cases, I will I will try to overestimate because I don't want to be waking up in the middle of the night. That's the fear that drives me here. So I will guesstimate and overestimate. The result will be waste of money. If I underestimated it for some reason, then I will have the reliability and resiliency issues like evictions, throttling, latency, etc. But what happens if I do not define them at all? Then it breaks the entire logic of Kubernetes orchestration. When scheduler places the pods on the nodes, it uses those definitions to allocate resources. And if you are not defining any resource, then Kubernetes assumes that you don't need resource. And once you are binded to some node with assumption that you don't need resources, and then you're trying to get those resources, what happens eventually? Kubernetes evicts you out, or evicts any other pod from the same node. Let's talk a little bit about the limits. What happens then? If we do not define limits, then we do not have any more a cut-off switch, which means that we can eventually, our tiny container can consume all the resources of the machine and crash the entire machine. And the blast radius of this will be huge. If we under-provision them, then again, the result will be not as expected. We will have reliability issues. What kind of reliability issues? We go up, we are under load, and we have our safety valve killing the pod. Killing the pod under the load. So load goes to the other pods, which are already under the load, so we can have even a domino effect, crashing all the pods of our application. A little bit too early. For the memory, if not defined, again, we can eat the entire memory of the machine. The only valid case not to have CPU limits is not to have limits is the CPU limit. The reason for that is a little bit complex. There is a lot of different topics in the internet you can review, but let me put it simple. If you don't know the reason why would you need the CPU limit and the CPU runaway is not the case, then you know why to put it. In most of the cases, you don't need it.
Okay, so set the CPU requests, don't set the CPU limits, just a rule of thumb without going into detail. Okay, so there is a lot of detail here. I remember when I first learned about Kubernetes, they told me Kubernetes is smart, it does automated bin packing. And I said, wow, some magic here. And now I like the way you put it. Kubernetes expects you to set and define these resources correctly. And here I was expecting of Kubernetes to do this work for me.
Yeah. So let's summarize it for a second. So Kubernetes expects you to do this work. And if you did it wrong, then everything goes wrong. And we evaluated the behavior of our cluster, and we understand that things are going wrong. We either wasting money, we either don't have enough resiliency, or both of them happening at the same time, which means it's time for optimization. Let's talk a little bit about the optimization, how this process works. So when we're talking about the optimization, it's actually not only cost reduction, but also resiliency improvement. We want each and every workload, each and every container, each and every replica have enough resources, enough to withstand the load, but not waste too much. How typical optimization process goes. So in Kubernetes, in software engineering, in private life, the algorithm is pretty the same. First of all, we need to be aware that somewhere in some particular place, there is a problem. Then we need to analyze this, all the data related and figure out what went wrong and how to fix it. Then we plan, then we execute our changes, and then there is additional step which is not listed here to come later on and make sure that we actually improved anything by doing all that.
Yeah, reminds me of my workout or diet, basically any process that is targeted at improving my life.
Yeah, but let's now try to scale this process to the reality of colossal ephemeral environments which Kubernetes are. And then we see some additional gaps. Okay, so we do have a monitoring solution. We do have all the data. We have ocean of data. But what do we do with the data? The first problem that we will hit is the pets versus cattle paradigm. Let me explain it in this way. If we have a single server or a single container, and we want to know everything about its health, then we can build a dashboard, put all the important information in front, and by single site, we will understand exactly what's going on. At the moment that we have thousands of them replicating the same dashboard again and again and again and looking at the result will not help us. We will get again into the ocean of data. So what we need is to build something that allows us to understand how the cattle behave and how to dive into which pet is sick and how to dive there and understand how to fix this particular pet. The second problem is prioritization. We have many of those pets. So fixing one not necessarily means that we will fix the important one. I will give you a short example here. Let's say we have extremely heavily over-provisioned workload, 500% more of the resources. But this one is a job running 1 minute in a month on extremely cheap spot instance. Would you care? Probably not. What would be the impact of changing anything? Probably nearly zero. But on the other hand, you may have slightly over-provisioned workload, which is running with 200 replicas on extremely expensive machine. Then the impact of change will be huge. The third thing, or the third problem, is collaboration. We as a platform engineers, as a DevOps engineers, not necessarily have the rights to change anything in a particular service. There is a notion of service owner. We left all the responsibility to our developers. And now we need to collaborate. We need a way to reflect to the service owner that this is a problem. And if we know how to fix it, then also suggest how to fix it. Last but not least is the repeatability. The process of continuous tuning of those 4 knobs is endless. Why it is endless? It is endless because of because our systems are constantly changing. Everything is constantly changing. The load patterns, the amount of users, the times that they are connecting and using the spike hours, etc. topology, the infrastructure, the architecture of our application, the code of the same application changes multiple times a day or a week. We build the continuous deployment for that. So all those are making the previous pattern unfeasible. We simply cannot use the previous algorithm that I showed with the 5 steps as we need to improve it.
Yeah, so we're always trying to catch our own tail.
Exactly. Not only that, we don't know where to start. So where do we start? Basically, the first step in the challenge is to establish a visibility. First of all, before we optimizing anything, before we changing, before we taking any action, the first thing we need to understand where we're standing. I suggest to start with simple evaluation of how the resources are behaving, how much we are paying versus how much we are allocating versus how much we are actually utilizing. Put some clear KPIs around that to understand are we satisfied with the picture or not, and where we need to invest. In many situations, the direction will be to cut some resources because we are extremely ineffective. But in some situations, we will need to add more resources because we are our uptime is not satisfying. It's always the balance between the resiliency and the amount of money. Then we need to learn how to take actions. The actions that we take are why it's a concern to take actions. We have GitOps. We can change everything. Its infrastructure as a code, change the value, run CI/CD, and everything is fine. But most of the like if I will come today to any organization and say the engineering department guys, you need to do cost optimization, in most of the cases, no one knows what is the action that need to be taken. Moreover, those actions in a view of engineering department considered as risky actions. Like my workloads are running fine now. And this guy and this CFO guy tells me to reduce resources. But when something went wrong, and I'm changing something that works, right? If something went wrong, I will be the person to wake up in the middle of the night to fix the crisis in production. I will be the one blamed for the problem.
I think the problem here is also that the impact of my changes is not clear to me. So this creates additional lack of knowledge, lack of understanding, and it's very scary to act in such an environment.
Yeah, absolutely right. And the last one is, okay, we can do this process once. And this is exactly where I started back in my career. I did this optimization manually. We invested a lot of time and effort to optimize the environment. And then 3 months later, we found again us in the same situation of doing this manually. This needs to be automated and streamlined as much as possible. So in the first phase, you want to understand how everything behaves. In the second stage, you want to be able to pick up the actions and execute them as fast as possible. At the third stage, once you are confident enough with the process, it's the time to start automation.
Right. And moreover, manual changes are error prone. So you may do it correctly once, but then the next time you'll make a mistake and you'll pay for that.
Absolutely.
Once it's automated and you fixed all of the errors, it will work correctly every time.
Yes, indeed. So here is the philosophy, like in DevOps, every good solution combines the technology with philosophy or methodology, if you will. And without proper methodology, technology will not help. Technology helps only to make the realization of the philosophy or methodology. So here is the methodology that we are suggesting, and here's the methodology that our product is following successfully. We have many success stories with big organizations that implemented exactly this. So the first stage is to observe, collecting data, observability, pretty simple. The second thing is to be able to analyze for a long period of time and correlate multiple data sources like cost, like behavior of HPA, like behavior of CPU, behavior of memory, changes in the code revisions, changes in the load patterns, seasonality waves, etc., in order to find two types of issues: the over-provisioning, where the resources are wasted, and the under-provisioning, where resources are where there is no enough resources and the resiliency of particular workload or entire cluster is at risk. Then it needs to go through the prioritization funnel. This is the place where you combining the impact of potential change, where you combine the impact with the action, right? And then once you have prioritized list of the changes that you would like to do, you can come and find the recommendations, what to do with it, what is the right solution. It's great to have underlying evidences at this point. It's great to have a service owner notion at this point. Then the execution can be manual, changing YAML, redeploying. It can be automation. It can be opening a ticket to the relevant developer and asking him to change something, anything like that. All this information eventually should be aggregated into trends, into the reports, where you can evaluate how the system behaves now, how it behaved previously, how it behaves now, and what is the next thing to do, which starts again with observability.
Yeah, basically, we need to observe the trends in order to make sure that we're actually optimizing.
Correct.
Okay. I love it. This is what stands at the heart of any DevOps transformation, right? This continuous process where we observe, prioritize, analyze, then act on that, and then go into it again. Continuously improving, hopefully.
Not hopefully, it's proven, it works.
Right.
Okay, I think let's pose for questions maybe, if anyone.
Yeah, let's see. We have any questions from the audience? Folks, any questions? Anyone? Okay, if not, then I have an interesting question. So basically, Kubernetes and any information systems that we're running are there to serve our business goals, right? So where in that loop are we correlating this with the business goals? So as you say correctly all the time, our goal is not just cost reduction. We also want to achieve the performance that is required for the business. So at what stage do we go to the business owner and tell them, here's what we have, here's what we're planning to do? Does this correlate with what business expects to achieve?
Yeah, so here we're talking about so-called day 2 operations. Day 0 is when we plan what we are going to build. Day 1 is when we're building our platform, our clusters, our applications, and day 2 is from the moment that we have all this beauty running, serving our happy customers for a very, very long period of time. So it's not one-time operation. Day 2 operations is continuous maintenance of what we have, bringing to the spotlight the efficiency of what we build. If we are inefficient and we have, then we struggle. We wasting a lot of time fixing those issues with the resiliency, with the waste, etc. So our goal as a business to make this day 2 operation to be as effortless as possible on one hand, and allow us to invest in innovation instead of sitting and tuning for knobs continuously across multiple clusters and endless amount of workloads.
Gotcha. And what's the vision there? So do you think that when I've achieved this continuous automation, do I still need to know how to set the resources correctly, or will we in the end have a system that's smart enough to set the resources for me?
So in my view, knowledge is a power. You better know how to do it, but execution can definitely be, how do I say it? The execution can be
Delegation.
automatically delegated to the automation, yes.
Okay, cool. So we have a question here from Joe, but I think Joe is asking about the product. So he's asking if we're in the data path and how we compare to other solutions like Spot from NetApp. And I think for that, the best thing would be to go to the demo and see what PerfectScale has to offer, and then maybe this will become more relevant, right?
Yeah, absolutely. So let's dive into some short demo of some of the capabilities of our platform, and then we will have more time for questions. Okay, so I will start, basically I will start here. This is the report. Sorry. Yes. So
First of all, a small prayer to the demo gods.
no, I just, yeah, not the demo.
I'll say the prayer, you do the demo.
Yeah, I need to switch here. Okay. Perfect. So here we are looking at the behavior of 1, 2, 3, 4, 5, 6 different clusters that we have here in our environment. This is the cluster cost for each and every cluster. Let's focus on the biggest one, the stable US. All right. This is the cost of the cluster. It's dropped here at some point, but this is not what we want to evaluate. What we want to evaluate is how the waste of this cluster behaves. Let's look into the waste. So we are wasting about $140 per week in this cluster. Let's see why. Let's break down this cluster into workloads. Here we see that $15, like 10%, is wasted in this particular workload named collector catcher. So let's see the cluster and this particular workload and understand how comes that this one is wasting money and why. So here is my cluster. In this cluster, I have 327 different workloads, deployments, stateful set, jobs, whatever things I have in my cluster. I'm currently observing my cluster over a period of 1 month. What do I see from the big picture of this cluster? I see that my utilization in 99th percentile is 64 cores of CPU, 222 gigabytes of memory. But if I'm looking at how much resources I'm allocating or how much resources developers asked to allocate, I can clearly see that they behaved like kids in a candy shop. They overestimated twice the amount of CPU. They overestimated nearly twice the amount of memory. But it's not end there, because we also have a cluster autoscaler, which is not perfectly tuned, which is scaling up by default 50% more of the resources of the request. So we ending up with 220 cores of CPU that we are paying for, while the utilization in 99th percentile, in 99% of the cases, measured every 30 seconds, is only 64. So we, and for the memory, it's even higher. So we are like overpaying 6 times for this entire cluster. And if we look at the particular workloads, and we will sort those workloads by waste, we will see this collector catcher, the waster, the one that we previously saw. So this is a collector catcher. It is a deployment. It is running in a namespace of prod for 1,700 hours in the last month. This is the total combined uptime of all the replicas that it had. And out of $75, we wasted here $56. Why? Or how come? So it was a single revision. This revision started back in January 3rd, and this we had somewhere between 3 to 5 replicas running constantly. We have 2 containers here, the Jaeger agent sidecar and the actual main business logic container. And this business logic container provisioned with 10 GB of memory as the request. And 2.5 cores of CPU as the request. This is the amount of resources that we are allocating for each and every replica. However, when we're looking at the utilization of this workload, what we learn across all the replicas is that we are utilizing somewhere around 2 gig of memory out of this 10 for each replica. The highest spike across all the replicas across a month was only 2.1 gigabyte of memory. So we're basically wasting 5 gigabyte of memory multiplied by 5 replicas, huge amount of resources. For the CPU, what we see is we're allocating 2.5 cores, but we probably not using a lot. Sometimes we have spikes, so it doesn't, but our spikes are never coming ever close to the actual reservation. Moreover, we have CPU throttling here because of the CPU limit. So PerfectScale comes with recommendations of how much resources we actually need to set. Those recommendations are here wrapped into the YAML file, so you can copy paste them into the infrastructure as a code, run CI/CD, and you fix the problem and saved $56 in a month for this cluster. In many situations, as I mentioned, you are not the service owner. You are manager, you are DevOps engineer, you are platform engineer, so you can go and create task. This task will go directly to Jira, will contain all needed information about what exactly need to be done. It will contain the link that will take the developer straight to the relevant workload and show him exactly the same picture. Then, yeah, they're pretty straightforward. The other capability, and this is how we can fix things manually. Understand what is the impact, what need to be fixed, and here we achieving both reducing, in this case, reducing the waste and also fixing the resiliency problem. The next thing that I wanted to show is the automated way that PerfectScale allows. So here, for example, all those workloads are automated. What does it mean they are automated? Yeah, gods off. Just a second, sorry. What does it mean the workloads are automated? It means that, one sec. Yeah, so it basically means that you specify a CRD or a label on a level of particular workload or entire namespace and say PerfectScale automations equal true. From this point, we are starting to be responsible for the workload. If we see that the workload struggles with under-provisioned resources, it have out-of-memory evictions or coming close to those problems, then we will step in and add more resources. So we will help this workload to survive. If we see that the workload is over-provisioned and wasting resources, then we will reduce resources, but we will do it gradually. We will take multiple iterations and we will make sure that during this reduction, nothing is being harmed. I will show only one example of such automation. Second. So this workload is, for example, automated, and this workload is continuously changing, means we are deploying different versions, and each version may have just, moving the pixel left to right does not really affect the behavior of our of our application, but in some cases you may introduce some big changes. So let's see what automation did here. We started with a very low amount of memory request, and the automation increased this memory request in order to make this workload work stable. This happened, we know exactly when it happened, why it happened, etc. So this work, so someone not needed to wake up in the middle of night to fix this workload. It happened automatically. Last thing that I wanted to show is the integration with Prometheus and Datadog. So all the information that we show can be also seen through the Prometheus and Datadog directly. We're supplying predefined dashboards, or you can use your own dashboards. And here you can understand all the rest of the information in the details. So this is how
you said Prometheus, but you meant Grafana.
Yeah, Grafana. You're right. I'm sorry. And all this is built in order to bridge this gap of the pets versus cattle, the impact versus change. Okay, the prioritization. We do all this in one place. Last feature that I wanted to show is the alerts. Every time we have a problem, the resiliency problem, we're managing a multi-cluster, multi-cloud environment. Let's say I am responsible for a namespace named Sun across multiple clusters. So I can see the active problems that I have across multiple clusters. I can dive into the problem. I will see, first of all, when it happened the first time, when it's seen the last time. I can assign this to me, and I can see all the details. I can either automate the fix. I can also view the details in the dashboard of my observability, but I am aware. I don't need to follow any channels anymore. I don't need to be afraid that I missed anything. Those are my active problems. Those are, those are my active problems happening now. This one is inactive, already not happening. It will be cleaned up automatically, zero maintenance here. So that was a short demo of some of the capabilities of the product.
Okay, so PerfectScale basically gives you the clarity regarding what changes you need to perform, and then also allows you to automate these changes so you don't need to remember to make them when they're needed.
Exactly.
Wonderful. And okay, do we have any more questions? No, still the same questions. So maybe you'll want to take this now. So Joe is asking, are you in the data path?
I'm not sure I understand correctly the question.
Yeah, same here. So Joe, if you want to clarify regarding the question, we'll be happy to answer. And
I think maybe Joe means does it require any changes in the code or anything like that? So no, we are stateless agent. You deploy us with a single Helm command. This also can be automated. And after you deploy us, that you getting this all this information automatically. So no code changes needed.
yeah, so just has like an appliance in front of all traffic. No, we're totally just a small agent in the cluster, monitors all of the resources, doesn't impact them in any way. And also another question, how does PerfectScale compare to specifically Spot? That's what Joe is asking.
Yeah, so Spot.io is a great solution to automate the Spot scaling. However, even when you're scaling a Spot instance, I'm still in the demo screen, right? So I'm still sharing my screen. So let's first of all evaluate how Spot instances behave here in my environment. For that, I will switch from the cluster view to the node reservation view. And what I will see is how many spots I have. So we introduced spots here. We have some amount of spots, but most of the cost actually coming was coming from the on-demand instances. Now we are about half and half. Then I can go and see how effective is this. So I will go into the info feed. I will select some cluster. I will select all of my spot instances. And what I will see, for example, and I will sort everything by, let's say, total cost. So for those spot instances, M6AX large, I'm using somewhere between 7 to 12 instances. I'm using here in, you know what, even those are even better example. I'm using here 8 by 32 because the assumption was that I will need memory intensive instances. However, when I look at the utilization of those instances, what do I see? I see that the utilization is actually somewhere around 2.5 cores. And again, this is aggregated data for somewhere between 5 to 8 instances over a month. I'm not utilizing this memory at all. I'm holding most of those instances because this insane request here, if I reduce these requests and get closer to this utilization, probably I'm going to get somewhere between 1 to 2 or 2 to 3 instances and not 5 to 10 instances.
And these are expensive machines, even when they're spots.
Yes, they are expensive machines. They cost twice than those.
Yeah. Okay. Wonderful. Wonderful visibility. And that's something that Spot doesn't provide you with.
Yes.
Okay. So Joe, hopefully that answered your question. Thank you. Joe says thank you, and thank you for the questions. Okay, Ellie, thanks for this great presentation. Thanks for the demo. I get excited each time I look at the demo, and each time I see you explaining exactly the benefits that PerfectScale can bring to anyone managing Kubernetes clusters. That can get really chaotic if we don't know what to do with them, right?
Yeah, and I invite everyone to start a trial with us. The trial is completely commitment-free. You simply go to the perfectscale.io, press this button, get started, and within 5 minutes, you can be onboarded. And then as part of your journey, we're also offering a free optimization session where we are showing you how to get most out of our product and our solution, and how to make your Kubernetes clusters to to be the most performing at the lowest possible cost.
So basically, I don't need to pay anything right ahead of time. Just connect my cluster, and then I can call you, Ellie, and ask to look at my cluster and tell me what I'm doing wrong.
Exactly like this. And we are SOC 2 certified, by the way.
Okay, so folks, what are you waiting for? Sign up. It's free. It's free to get started. And then if you like it, you can continue enjoying it in the long run. Okay, let's get those clusters optimized.
Thank you very much. Thanks, Anton.
Bye.